in 10th class, 6th chapter. Now, 7th session. In this session, we are going to discuss about the magnetic quantum number. We have already discussed about the principal quantum number and the angular momentum quantum number. We know that the principal quantum number tells us about the energy level and size of the orbit in which the electron is revolving around the nucleus in an atom. Means it refers to the orbit. The second quantum number, that is angular momentum quantum number, tells us about the suborbit or subshell, the shape of the subshell is identified by the angular momentum quantum number. Means principal quantum number tells us about the orbit, angular momentum quantum number tells us about the suborbit, the magnetic quantum number tells us about the orbital. It refers to the orbital. The magnetic quantum number is denoted with the ml. It has the integer values between -L to +L including 0. For a certain value of L, there will be 2L plus 1 integer values of ml, -L to +L including 0. These values describe the orientation of the orbital in space relative to the other orbitals in the atom. Means the magnetic quantum number tells us about the special orientation or special character of the orbital in which the electron is revolving around the nucleus in an atom. If the L value is 0, there will be only one value for the ml. L is equal to 0 means 2L plus 1 is equal to 2 into 0 plus 1 is 1. There is only one value of ml. This value is 0. That is called the s orbital. And when L is equal to 1, there will be 2L plus 1 means 2 into 1 plus 1 is equal to 3 ml values, namely -1, 0 and +1. Or these three values refers to the p orbitals, px, py, pz. Their orientation is along x-axis, y-axis and z-axis. That's why they are called the px, py, pz orbitals. These px, py, pz, three orbitals have the same energy level. That's why they are called the degenerated orbitals. Orbitals in the subshell belonging to the same shell possess same energy. That's why they are called the degenerated orbitals. Okay, for L is equal to 0, that is the subshell is S. Number of degenerated orbitals are only 1. For P means L is equal to 1, there will be 3 degenerated orbitals px, py, pz. For the ml values -1, 0, +1. And for the L is equal to 2, subshell is D, we know it. And for this, the ml values are -2, -1, 0, +1, +2, dyz, dzx, dxz and dx square minus y square, dz square. These 5 are the d orbitals. For L is equal to 3, that is the F subshell, there will be 7 degenerated orbitals. Okay. For the first shell, n is equal to 1, L is equal to only 0, that is S subshell. There will be only one orbital, that is S orbital. Only one orbital, that is S orbital. Only one subshell, one orbital. That's why it is called the 1s orbital. Whereas this it will be in the spherical shape, and in the second shell there will be two subshells, S subshell and P subshell. In the S subshell there will be only one orbital, because for L is equal to 0, ML values are only 1, that is 0, ML is equal to 0. That's why that is 2s orbital. For the L is equal to 1, L is equal to 1, in this orbit there will be 3 ML values. They are -1, 0, +1. They are px, py, pz orbitals, degenerated orbitals. That's why in the second shell there will be 4 orbitals. One is s orbital, 3 are p orbitals, 2s, 2px, 2py, 2pz. Okay, p orbital has the dumbbell shape. P orbital is dumbbell shaped. Whereas in the third shell, means n is equal to 3, there will be 3 values for the L. L is equal to 0, L is equal to 1, L is equal to 2. For L is equal to 0, ML is 0, that is 3s orbital. For L is equal to 1, there will be 3 ML values, -1, 0, +1, 3s, 3px, 3py, 3pz. And for L is equal to 2, in the third orbit, there will be 5 ML values. For the L is equal to 2 subshell, that is D subshell. They are, here we can see them, D yz, D xy, D xz, dx square minus y square, dz square. It has the double dumbbell shape. D orbital has the double dumbbell shape. Okay. In the third shell there are 3 subshells, S, P, D subshells. In the S subshell there will be one orbital, that is 3s. In the P subshell there will be 3 orbitals, 3px, 3py, 3pz. In the L is equal to 2 subshell, that is D subshell, there will be 5 orbitals. Total 9 orbitals. In the first shell, 1 subshell and 1 orbital. In the second shell, 2 subshells and 4 orbitals. In the third shell, 3 subshells and 9 orbitals. Means the number of subshells is equal to the n value in an orbit, and number of orbitals is equal to the n square. In the 1 only, in the 2 4, in the 3 9. Here we can see it. N is equal to 1, L is equal to 0, ML is also 0, that is 1s. Number of orbitals is 1, subshell 1 and orbitals 1. In the second shell, n is equal to 2, L are 0 and 1, ML values for L is equal to 0 is 0. For L is equal to 1, -1, 0, +1. Total 4 ML values. 4 ML values means subshells are 2, n is equal to 2, subshells are 2, and orbitals are 4, 2 square 4. In the 2s only one orbital is there, in the 2p 3 orbitals are there. In the same manner, in the third shell For the third shell, n is equal to 3 and L values are 0, 1, 2, and for L is equal to 0, 0, that is 3s orbital. For L is equal to 1, minus 1, 0, plus 1, 3p orbitals. For L is equal to 2, minus 1, minus 2, minus 1, 0, plus 1, plus 2, 3d orbitals. They are, for L is equal to 0, 1 orbital. For L is equal to 2, for L is equal to 0, 1 orbital. For L is equal to 1, 3 orbitals. For L is equal to 2, 5 orbitals, total 9. That means n is equal to 3 here. That's why subshells are 3, orbitals are 9. In the same manner, for the fourth shell, n is equal to 4, subshells are 4, orbitals are 4 square, 9, 1, 3, 5, 7. Total 4 square, 16. 4 square, 16 orbitals are there in the fourth shell. You can observe this one in here. For the S subshell, number of orbitals are only 1, maximum number of electrons 2. Why? Because for each orbital only 2 electrons can occupy it. Means each subshell holds a maximum of twice as many electrons as the number of orbitals in the subshell. Means in an orbital there will be only 2 electrons can occupy it. That's why in the first shell, the number of orbitals only 1. That's why 2 electrons. You can find it with the 2n square formula also. First shell 2 into 1 square 2. In the second shell, orbitals are 1 plus 3, that is 4. 2 into n square, 2 into 2 square, 8. In the same manner, in the third shell, 2 into n square, 2 into 3 square, that is 9. 9 into 2 is 18. Total of 18 electrons in the third shell. In the fourth shell, there will be 32 electrons. 2 into 4 square, that is 16 into 2, 32 electrons. In this way, we can know the number of orbitals, number of subshells, number of electrons in an orbit. Okay, thank you very much.